something about these solutions. Okay. Now, all of us, we know what is a solution. So, can anyone tell me the definition of solution?
It is a homogeneous mixture of two or more substances.
Very nice, very good. But I shall add one more, two more words in the definition, whatever you have mentioned. Why am I going to add? See, to get a solution is not that we can mix anything. To get a solution, we should mix those substances which do not react with each other. Because solution is a mixture. And the principle of mixture is that if you wish, you can separate them. So I cannot mix an acid and base together and stir it and make it homogeneous. So in that case, two extra words I have to use in your definition. So right now it is solution is a homogeneous mixture of two or more non-reacting substances. Okay. This is the word that I have read. Then it becomes a foolproof definition. Nobody can question. Now, substances which make the solution are called components. That you see, whole solution chapter is there in first one. That we will read detail. But still.
You have already done this, sir, yesterday.
Oh, yesterday I have done, na?
Yes, sir.
Oh. Yesterday I have done with you this molality, na?
Yes, sir.
No, molarity I have done. Molality I have not done.
No, sir.
I have done molarity, na? Okay, okay. So today we'll do molality. What is molality? It is the number of moles of solute present in per kg of the, I'll underline this one. See, in molar solution, we have mentioned per kg of the solution. Solution means it contains both solvent and this solute. But what does it say here? Per kg of the solvent. That is, you have to take 1 kg of solvent and after that you add the substance. Per kg of the solvent. Okay? It is expressed as, please remember, it is small m, not capital. Okay? So I'll write now here. Therefore, M is equal to number of moles of solute divided by solvent in E. Okay. So let me write here. See, I told you by convention we consider A as solvent and B as solute. Let WA and WB be the mass of solvent and solute respectively. NB is the mole of solute. All right. Then I'll write now here M is equal to NB by WA in AT. But we know NB is equal to what? Mole, I told you how to find. Weight of the substance divided by molar mass. One more approach. And MB is the molar mass of solute. So I'll write now here WB by MB. So let me put it here. So I'll write now here M is equal to WB by MB divided by WA in E. Okay. Or I can write M is equal to WB by MB into WA in kg. Now I'm to convert into gram. I already showed you. If you divide it by 1000, then it gets converted into gram. So I can write ultimately, or MA equal to WB by into 1000 MB WA in. So this is my final equation.
Done, sir.
Okay.
Done, sir.
Up. Wait. Okay. Now we'll do what's very simple sum. Calculate the molality of 15% H2SO4 solution by mass, means mass percent. Okay. So let me write this equation. M is equal to WB 1000 MB into WA. See, what is the meaning of mass percent? In mass percent, amount of solute in gram present in 100 gram of the solution. 100 gram of the solution. See here, we do not have any weight of solution. We have weight of solute, weight of solvent. Okay. So now see here, what is the mass of solution? Did I show you? Mass of solution is, solution contains solute and solvent. So mass of solute plus mass of solvent. Okay. So I have to find out the mass of solvent. So mass of solvent is due to mass of solution minus mass of solvent. So mass of solvent is what? See, mass percent means what is the mass of the solution? 100 gram. And how much solute we have? 15 gram. So it is 85 gram. Okay. Now what is WB? WB is this one. MB, you know, sulfuric acid is what? 2 atomic mass of hydrogen is 1. Sulfur is 32. You have 4 oxygen. So it becomes 2. So put all these values and find out the molality. Do it. Please do it. I was a visitor. Just I'll go and meet him and come back. So do. Just do it. So now I'm going to introduce to you another term. So what is the result? You did not tell me.
So 1.8.
Yes. Try to do some numerical from your book.
So 1.8, sir.
Okay. Now we write here. This one we are often going to use it in future. We call it mole fraction. So it is the ratio between the number of moles of any component of a solution and that of the number of moles of all the components of the solution. Don't get confused. Suppose I have taken solute B dissolved in solvent A. So I can find out the number of moles of solute. Or how? By dividing WB by MB. I can find out the number of moles of the solvent by dividing WA by MA. You know, weight of the solute divided by molecular mass. So now, if I am to find out the mole fraction of the solute, then what I'll do? On the top, I'll write the mole fraction of solute divided by the mole fraction of all the components. In the solution, what are the things are there? Solute is there, solvent is there. So I'll divide it by the number of moles of solute plus number of moles of solvent. That is called mole fraction. Clear? Now, it is denoted as see there, this is not X. See, this is longer. So this is called chi. This is a Greek letter. Okay? Let me write now. Let NA and NB are the number of moles of solvent and solid. Okay? And chi A, chi B are the mole fraction of
Now,
solute
total filter game.
and solvent respectively. So therefore, what should I write here now? Mole fraction of A means solvent is equal to what? Chi. So it will be what? Na by Na plus N. And mole fraction of this. What is this? NB divided by Na plus N. Now, dear, how will you find Na and NB? This is easy. I have already taught you. Na is mass of solvent divided by molar mass of and mole fraction of solute. Sorry, moles of solute is you should know because you have to do numericals. Huh? Oh, জল আইছে না বাবু জল আইছে বাবুরে আমি জলটা দেখ বাবা দুদিন ধরে জল আসে আমি তো ক্লাস this so write up to this now I'm করছি
কমল না বললে তো আমরা বুঝতামই না
আমি যেরকম কাল পানি आएगा वह आएगा
So done.
okay now see here so now let us add now chi A plus chi is equal to what? Na plus N. This is equal to Na plus N is equal to what? Na plus NB divided by Na plus N. So is equal to 1. So it is a very famous saying. What should I say? Sum of mole fractions of all the components of a solution. See, here components I have taken 2, so it is Na and B. If you have taken 3, so it will be Na plus Nb plus Nc. Okay, so chi A plus chi B plus chi C. Sum of mole fractions of all the components of a solution is equal to unity or 1. This is extremely helpful for us to know. Okay, now with this one, I can write another formula for molality. Please remember, molality. What did you write here? WB into 1000. This I am giving only for your entrance exam. MB into WB. So this is for your solute, or this for solvent. From there, okay, we can get another relation. See, before that I like to write here. See, if you know,
আসছে তো কয়েকটা ভিতরে নিয়ে নিলেই ভালো হয়
এই তো সময় শুরু হলো।
কে নেবে
See,
তারপরে জল
if you know the mole fraction of this, see, if you know the mole fraction of this one, and if you don't know this, what you can do? The chi B is equal to 1 minus chi A. All right. So this one we can write another equation like that. Wait a minute. So in that case, what I can write here? For this, I can write here chi B into 1000 1 minus. So I can write now here chi A is equal to 1 minus chi B. See, this is also a very important relationship by which you can find out the molality of solution. Right. I am going to give you some numerical. I know you will not do the numerical. Even if I waste one class also, I don't mind, because you will answer. calculate the mole fraction of 15% glucose. Glucose is C6H12O6. Solution. So you have to find for both of glucose and water. So can you? I will not give you the molecular mass because I told you how to find it. If you cannot, then I'll help. You have to find for both for water and this thing. Look, it is 15%. Do. বুঝিও বুঝে না জলটা চলে যাবে তো বাবা অল্প জল হ্যাঁ সব গামলার মধ্যে সব ভরে গেছে আমি পাইপ নিয়ে তুমি গামলার জলটা আগে কবেছে ঢেলে আজকে 5 মিনিট ঢেলে গামলাটাকে বাথরুমে নিয়ে আসো So how you do it? Mole of what? Glucose. So what will write now here? WB glucose by MB glucose. How much amount of glucose is there? How much? Huh? Right here now. Mass by volume. No, by mass. See how much amount of glucose is there? It is 15% now. So what is the mass of the glucose? Don't remain quiet.
80, so 180.
180.
No.
So 180.
180 is molar mass. How much amount of glucose is there in the solution?
15 gram.
Yes, correct. So it is 15 divided by 1. Okay. So what we can write now here? Moles of
So how did you get 180, sir? So how did you get 180?
Okay, I'm doing it. Don't worry. So it is, see here, C6H12O6. What is the atomic mass of carbon? 12.
So 12.
6 into 12. 12 into 1. 6 into 16. That is equal to 180. See, it is the molar mass of glucose or no?
Yes, sir.
Then moles of what? Water. So let me write here now. It is, okay, you write here NC6H12O6. So it is NH2O. See, what is the mass of water? In 15% by mass solution, if 15 is the amount of the glucose, how much water is there?
85.
85. 100 minus 15. Good. So it is 85 divided by, what is the molar mass of water? 18. Okay. So this one, these two you find. Then I will help you. No, I will not help you. First you do, then I will help. I'll show you.
Sir, done.
Okay. How much it comes?
0.08.
0.0. And how much it is?
4.72.
4.72. 4.72.
4.723.
Okay, right? Yes, 4.7. Okay. So now you find out. Say you want to find here chi A. Chi A is what? H2O only. Or you can write here H2O. So it is what? NH2O divided by NH2O plus N glucose. So put this value and find it. Then you can. So do now. Next. आपके जो लाइले फिल्टर इसे जिक्र को स्टॉप करो तो मुझे थोड़ा So how much did you get?
So 0.93.
0.9.
98.
How much?
98.
0.93. 0.982.
982. Okay, see, mole fraction does not have any unit. Why? See, this is also moles, this is also moles. So there is no unit. Is a ratio. Then what about the mole fraction of glucose?
Sir, 0.001.
So how did you find? Did you do the same calculation like this?
Yes, sir.
No, you should not have. See here, is it not this? See, it is 0.982. Because of that I told you that you should remember that. See, it is containing only one solute and one solvent. So in that case, chi A plus chi B is equal to 1. So you know already. You know one of the other one you can find by subtracting from 1. All right. Now, I'll do now little extra. This is again I'm telling you for your entrance. Okay. This is called dilution. In my note, it is given there. Say you have taken a molar solution of molarity M1 and V1 is the volume. To that you have added water. So the volume of the solution has become V2. But how can you calculate the molarity of this one? So for the simple formula is there. So I'll write down here. 1. If a solution of M1 V1 is diluted to M2 V2. This is the new molarity and this is the new volume. Then M1 M2 V2 is equal to M1 V1. Okay. So let me give one numerical. calculate the molarity of a solution so okay molarity of a solution of 5 molar if with 200 ml of a 5 molar solution diluted to 500 ml. Do. This one you can do without calculator also. So what you are going to do? You will write. We know M2 V2 is equal to M1 V1. See, M2 you are supposed to do. No. So that you do not know. What is V2? What is the final volume? 500 ml. What is the original molarity? 5 more. 5. And what is the okay 5 more. And what is the original volume? 200. I told you, no? It's very simple, but I do not know why it is not being given in your textbook. Your textbook is very funny.
Done, sir.
So, what is the value?
Sir, 2 molar.
So 2.
Okay.
2 molar.
So this way you can calculate the molarity of a new solution. This is required for your practical DI, but nowhere in the book it is mentioned. Because you will be doing it in your class 12 practical. Okay.
So what's the unit of molarity?
Huh?
So what's the unit of molarity?
Again, you tell me, your voice is not clear.
So what is the unit of molarity and
Oh,
molality?
grams per liter, Khun. Grams per liter. Okay. If two solutions M1 V1 and M2 V2 of a same solute is mixed, then the molarity of resulting solution will be, say, I have taken this much volume, so it is V1 and molarity is M1. And I have taken this much volume, V2 of molarity M. If I mix them, what is going to happen? You will find the volume will be large. So it is, say it is V. And you have a new molarity, M. Then it will be what? Huh? Then, oh sorry, molarity of the resulting solution will be M1, M will be equal to M1 V1, M2 V2 by V. So what is V here? What is V here? You can write here now. This. Okay, I'll write in one step. V1 plus V2. So it is what? What is V? It is equal to V1 plus. Okay. What will be the molarity of a solution which is obtained by mixing 200 ml of 5 molar and 300 ml of 2 molar HCl solution. Do.
So can you dictate the question because the screen is not clear? Sir? Excuse me, sir?
Sir, done.
So
How
done.
you do it? You write now. You know M is equal to M1 V1, M2 V2, and V1 plus V2. Please remember, whenever you do numerically, you should write all these values. Then you will get mark. And if you don't write, you lose half mark. Say it is M1 is what? This 5 molar. Okay? Write 5. V1 is what? 200 ml. M2 is 2. V2 is 300. So put the value. Just for writing, see, for writing this one, you get half mark. For writing this, you get half mark. And for writing this one, you get, oh, sorry. Then you put the value. After putting the value, you'll get half mark. Result, half mark. So you'll get 2 marks. If you skip any step, that mark will be deducted.
So done.
So what is the new molarity?
Sir, 3.2 gram per liter.
3.2 gram.
So now you have learned how to do this one. Okay. Numericals are not to be scared, but if you do not do numerical, then you do not understand the theory. Okay. Now I'll go for another one. Okay. Of solution is called parts per million. Okay, we call this one as ppm. You have already heard about it. This unit is used if the amount of solute is very, very less. And generally we use this term to express the concentration of the contaminants in air or water. This is called pollution, or soft hardness of water, calcium and magnesium. All right. It is defined as.
Sir, can you tell me the page number, sir?
What page number, dear?
Sir, from the book.
I'm not carrying the book, dear, with me.
Okay, sir.
It is there in your that note I have sent. It is there. It is defined as the most of the thing I teach you just from my heart. It's not that I by hearted. Quantity of the solute in grams present in 10 to the power 6 gram means what? 1 million. Of the solution. So how can I write now here? What is ppm now? ppm is mass of the solute in grams. Sorry, sometimes ink betrays. Mass of the solution into 10 to the power 6. Okay. This concentration term is used when the solute is present in trace quantities. Example, pollution. hardness of water, etc.
Sir, is this included in ISC?
Yes, everything is
So because
same. ISC sometime when I
no, I
teach
did.
extra, when I teach little extra minded, this one I have taken an ISC book. My note incorporates
Okay.
CBSC, MBOS, and ISC.
Okay,
Okay,
sir.
so ISC syllabus is little bigger than MBOS and CBSC.
Yes, sir.
So can I take now 10 minutes extra? Today I don't have any class 12 class. Do you have any
Yes,
other
sir.
tuition?
No, sir.
No, sir.
So now we have done with the solution. So now we will go for chemical equation. What is a chemical equation? See, when we can speak something, but if you want to send the information to someone in black and white, you cannot speak. So you have to write. So chemical equation is nothing but the symbolic representation of a chemical change. A chemical equation is the symbolic representation of a chemical change. Okay, example. Say I have taken here sodium hydroxide and I have taken here HCl. It undergoes neutralization. So this is the one. What are the information that we obtained from chemical equation? A chemical equation is balanced. Balanced following the law of conservation of mass. I told you, conservation of mass. What are the information we obtain from a chemical equation? Informations obtained from a balanced chemical equation. One. What are the reactants? See, reactants are written on the right hand side, products on the left hand. Sorry, reactants are written on the left hand side and products are written in the right hand side. Reactants and these are the products. What are the reactants and products? Involved in chemical change. Second, the relative number of atoms or molecules of reactants. And products. Is how many you get. Third, the relative amounts by mass of reactants and products. See, you know, sodium hydroxide is 40 gram. This is 36.5 gram. This is 58.5 gram, and this is 18 gram, because we know the atomic mass. Relative volumes of reactants and products. If they are gaseous, then you can find out. Here we say 1 mole, there we will say 1 volume. 1 mole of sodium hydroxide reacts with 1 mole of HCl to give 1 mole of sodium chloride and 1 mole of water. That is by mass. If it is gaseous, then we'll say 1 volume of this reacts with 1 volume of A reacts with 1 volume of B to give you, say, 1 volume or 2 volumes, such and such. So these are the informations. Well, after that, we will write what are the informations you do not get from chemical equations.
Done.
Okay, now information is not obtained. Okay. So right now here, limitations. actual concentration of reactants and products cannot be obtained. Now see here, very nice. Here I have found that one mole of sodium hydroxide reacts with 1 mole of HCl. Instead of 40 gram, I may take 4 gram. Instead of taking 36.5 gram, I may take 3.65 gram. But in equation, though, we never write below how much we have taken. So actually, you do not know what is the concentration of the reactants and what is the concentration of product that you have got. Second, time taken for completion of the reaction cannot be obtained. Whether it takes 1 minute, 1 hour, 10 hours, or 1 full day, that we do not know. The physical state of the reactants and products are not mentioned. See, you are a student of chemistry, but you do not know what type of substance exists in which state, whether it is solid, liquid, or gas. No, it is also not there. Later on, we have modified, no doubt, but in original equation is not there. Sodium hydroxide, whether I have taken solid or solution, that you do not know. HCl, whether I have taken gaseous or aqueous solution, that also I have not written there. Conditions like temperature, pressure, exposure to radiation. Many reaction takes place on heating. Some undergoes done in presence of pressure. Some has to be exposed to light, exposure to radiation, etc. for bringing chemical change is
Pardon, sir?
conditions like temperature, pressure, exposure to radiation, etc. for bringing chemical change is missing. We don't write. Whether the reaction is reversible. Some reaction again from product you get to the reactant is reversible or irreversible. Whether the reaction evolves heat. We call it exothermic. Like if you mix sodium hydroxide initially, it produces heat. Or absorbs heat. We call it endothermic. So these are the limitations of the chemical reaction. Okay, now the different methods which are used for balancing chemical equation. Balancing chemical equation. You have only done the first one. This is called heat and trial. So we go on practicing this one, following what? Following only the law of conservation of mass. Okay. Second, partial equation method. So I will not do it now. When the time comes, we'll do.
So what's the first one?
Heat and trial method. Third is oxidation number method. That is there in your syllabus. In second book, this is the first chapter. Oxidation, that we'll do in class 11. Oxidation number method. 4, ion electron method. That is also you'll do in class 11 when we go to the second book. Okay. So this much is enough for today.
So can you tell the second one and the fourth one? I cannot see.
Heat and trial method, partial equation method, partial equation method. Third one is oxidation number method. And the fourth one is ion-electron method.
Okay, sir. Thank you.
Okay, well.